Thank you for the warm introduction. It's really an honor to be here. As I was preparing for today's event, I put on this shirt made of polyester. I used my cosmetics neatly packaged in polyethylene containers, and before I headed out the door, I put on these shoes that have a polyurethane sole. On the bus, I wore a face mask lined with polypropylene, and I kept an eye out for my stop on the screen made of polycarbonate. Plastic is everywhere. It's in the single-use products that we despise, but it is also in the devices, vehicles, and infrastructure that we depend on. Just today, we've learnt of several innovations ranging from bionic devices to light spectrum shifting dyes that will leverage plastic in some way to change the world. It's an incredibly versatile and useful material, but the great tragedy of plastic is that we never resolved its end-of-life fate. The reality is that no matter how much you and I meticulously sort our plastic waste at home into the yellow curbside bin, the majority of the waste that we produce and consume does not make the cut for traditional mechanical recycling. It's too contaminated, it contains dyes, or it's mixed with other plastics. And if it's textiles we're looking to recycle, we can forget about it. Usually, only the cleanest, clearest plastic is accepted into the mechanical recycling process, where it then gets melted and reformed into recycled plastic. But with each cycle of this process, the plastic loses some of its quality and structural integrity. And after about 5 cycles, it meets the same fate as the rest of our plastic waste. Over 9 billion tons of virgin plastic have been produced from fossil fuels to date. Yet only 9% of this has been recycled. The balance is accumulating in landfills and the natural environment. More than just a problem of waste, the production of virgin plastic is projected to contribute up to 15% of total carbon emissions by 2050. Now I know what this looks like. 9 billion tons of insurmountable, worthless plastic waste. But what if I told you that this is actually 9 billion tons of one of the most valuable resources on Earth? What if I said that we can mine this rich and abundant resource for enough raw materials to create not just brand new plastics, but other fossil fuel replacing chemicals to sustain countless future generations? And what if I said that our ability to do this is critical to cutting ties with fossil fuels? At Samsara Eco, we have developed a technology that can transform this waste into brand new virgin quality plastics and other valuable chemicals using highly engineered enzymes. Enzymes are the blue-collar workforce of nature. They're the tiny molecular machines that are responsible for catalyzing the reactions essential to all life. They're so catalytically powerful that we've been using enzymes industrially for over 100 years in textiles, detergents, and the production of food. Drawing inspiration from nature and learning from millions of years' worth of data on how enzymes evolve and function, we can now leverage AI to design new-to-nature enzymes with the catalytic properties that we need them to have. With this approach, Samsara has developed plastic-degrading enzymes that can rapidly degrade different plastics all the way to the basic chemical building blocks that they're made of. Here's how it works. We take your biscuit trays, fast fashion clothing items, and colored drink bottles, and using our enzymatic process, we convert them into their constituent chemicals known as monomers. These monomers are no longer identifiable as waste. They're simply a pure, raw material identical to what we extract from fossil fuels today. And suddenly, we've unlocked unlimited possibilities for what these monomers can then become. They can, of course, be used to make virgin quality plastics again, with no compromise to the quality of the plastic over an infinite number of cycles. Or using our library of engineered enzymes, we can convert these monomers into other valuable commodity chemicals, such as those used in textiles, electronics, or even construction, creating value for what was once considered waste. With this technology, our experienced and growing team of scientists, engineers, and business people are bringing infinite plastic recycling to the world. Our technology is proven at the pilot scale, and we're performing trials to produce new bottles and fibers with the largest consumer goods companies in the textiles and packaging industries. We've also been supported by some of the world's leading investors, including Main Sequence Ventures, and have strategically partnered with industry leaders such as Woolworths and Lululemon. And now we're accelerating towards our 2030 ambition of recycling 1.5 million tonnes of plastic per year, preventing an estimated 2.5 million tonnes of CO2 emissions annually. And this is just the very beginning. There is a future in which the polyester in our clothing, the polyurethane in our shoes, and the polycarbonate in our screens all have infinite lifetimes. And a future in which all of the plastic that we depend on is produced from the 9 billion tonnes of plastic that already exists instead of fossil fuels. But it will take more than just cutting-edge enzyme technology to get there. We need industry to lean into new technologies and take responsibility for the waste that they produce. We need investment in advanced recycling solutions and infrastructure, and we need policy and regulation to curb virgin plastic production. Beyond recycling, reducing, reusing, and even redesigning the plastics that we consume all have a role to play. So no matter what your sphere of influence inside and outside of this room is, remember that all of the plastic we'll ever need has already been produced. With infinite plastic recycling, we can view waste as a valuable resource and begin to build a world where we never need to exploit the Earth's natural resources to make plastics or chemicals again. Thank you.
Amazing. Amazing. Thank you.